All right. So, how do we figure out if an ordered pair is a solution to two equations? Plug it into both. Plug a 6 here, 7 here. We get 42 minus 7 is 49. Does that work? 42 minus a negative 7 would be 49. 42 minus 7 is 35, right? So this is no way, Jose. It's got to work for both. Like if it works for the second one, because this is 36 minus 21, which is 15. It works for that one, but this one is no. It's got to work for both to be a yes. If it works for one, not the other, it's a no. Okay, if it works for neither, it's a no. It's got to work for both, then it's a yes. Substitution method. When it's a substitution method, we get one variable alone. Once one variable alone, we plug what that is equal to into the other equation, we solve, and then we resolve back. So what's the easiest variable to get alone here? X in the second equation. X equals 73 plus 8y. So we take this and plug it in for the x of the first equation. So 5 times 73 plus 8y plus y equals 37. 5 times 73 is 363 plus 40y plus y equals 37. Subtract 363 from each side. Oh, it's not 363, it's 365, right? Subtract 365 from each side. So 41y equals a negative 338. No, I'm 328. 328. That makes sense. Divide by 41. Divide by 41. So y equals a negative 7. Once y equals a negative 7, we plug it back into here. X equals 73 minus 56. So x would equal 17. So the solution as an ordered pair would be 17, negative 7. To check your answers, plug them in the other equation. 5 times 17 is 85. 80. Ooh. That makes a difference. So that's 64. 73 minus 64 is 9. So 9, negative 8. If we put a 9 in, it's 45 minus 8 is 37. That works. That's why we plug them in at the end, just to see if we made a mistake along the way. Okay, on this one, what I would do is I would divide this first equation. Everything's divisible by 3. So it's x plus 2y equals 9. So x equals 9 minus 2y. And take this and plug it in for x. 4 times 9 minus 2y plus 16y equals 20. 36 minus 8y plus 16y equals 20. Negative 8y plus 16y is 8y. We subtract 36 from each side, it's negative 16. So y equals negative 2. Plug that in for here. 9 minus a negative 4 is 9 plus 4, which is 13. So it's 13, negative 2. We try that in there. 3 times 13 is 39. But then I made another mistake, didn't I? Jeez. Guess I can't do math today. 3. X minus 2y equals 3. So x equals 3 minus 2y. Move the 12 over, it's 8. So y equals 1. If y equals 1, x equals 1. 1, 1, 1, 1. Yep, that works. Okay, I don't think we need to do a third one. Ooh, or do we? No, we don't need to do a third one. Okay, now, what if we have a squared in it? If y equals x squared, I just take the x squared, plug it in for y. I don't take the square root of each side. That wouldn't help me. So x squared minus 1 equals 0. So that factors into x plus 1, x minus 1 equals 0. So x equals negative 1 and 1. Okay. So if x equals negative 1 and 1, then I plug those numbers back into here. Negative 1 minus 1 is negative 2. Wait. Actually, negative 1 minus 1 doesn't equal 0. So negative 1 is not an answer. Ooh, x is negative 1. Okay. So if x is negative 1, y is 1. And if x is 1, y is 1. So both of those make this work. So we have two sets of answers. Because when we plug it into this equation, because we can't plug these into the second equation because they're x values. So we have to plug them into this top equation. Negative 1 squared is 1. So negative 1, 1. And if we check it in the other equation, 1 minus 1 is 0. And so on. Okay. Elimination method. This one's set up perfectly. You add the columns. 2x equals 16, so x equals 8. 8 plus what is 6? Well, 8 plus negative 2 is 6. 8 minus negative 2 is 10. 8 negative 2. Now, not every problem will be set up perfectly for you. See how the y's are opposite signs. I want to keep the signs opposite. So I want to multiply the top row by 2 and the bottom row by 3. By multiplying this by 2 and this by 3, we get negative 6y here, positive 6y here. They'll cancel when we add. So 8x plus minus 6y equals 46. And then 9x plus 6y equals negative 12. We add 17x equals 34. X equals 2. Once you figure out x equals 2, you plug it back into here. 6 plus 2y equals negative 4. 2y equals negative 10. Y equals negative 5. So the ordered pair is 2, negative 5. We stick a 2, negative 5 in here. 8 minus a negative 15, or 8 plus 15, is 23. It checks. I'm going to skip over 8, and I'm going to do 9. On number 9, okay, I want to create opposites out of my y, so I multiply both top and bottom by 2. So I get 8x minus 6y equals 4. My bottom equation is negative 8x plus 6y equals negative 4. If I add my columns, what do I get? 0 equals 0. Does 0 equal 0? Yes, if the variables disappear, and 0 equals 0, or 5 equals 5, or 20 equals 20, there's infinite solutions. That happens when all the variables disappear. If your variables disappear, and you get like 0 equals 12, then that would be no solution. So 0 equals 0 is infinite solutions. 0 equals 12, or 0 equals 20, or 0 equals whatever is no solution. Okay? So you have 9 problems to get going with. You've seen this before. You've seen this several times in your past math career. This is just to remind you what to do. So you will go through these, and then we'll have a second section of other ones looking at graphing them. So we'll look at the graphs of solving equations simultaneously.